Hi there, this is GCSE Physics. This one's Atomic Structure Lesson 9, Irradiation and Contamination. So the objectives are to explain what irradiation is and how it can be useful in food production and in sterilising equipment, and to explain what contamination is and to give examples. This is quite a wordy one. You will have to be pausing a lot and probably do some reading as well as listen to the explanations, and maybe you want to take some notes, so please remember to pause. So, radioactive isotopes. Radioactive isotopes emit radiation, alpha, beta and gamma, and also high-speed neutrons can all cause ionization. The alpha, beta and gamma is covered in quite some depth in previous lessons. Ionization is where the radiation strips electrons away, which turns atoms into ions. Remember, atoms have to be electrically neutral, so they have the same amount of protons as they do electrons. When electrons are stripped away by radiation, there are less electrons, which means you have an excess of protons, so they become charged, and we call them positive ions. You should do that in chemistry. Ionizing radiation can cause dangerous mutations in cells and lead to cancer. Just flick that back on in case you missed that. Irradiation. So irradiation is where an object is exposed to nuclear radiation. We say that an object has been irradiated. So if you've played Fallout, this is my VATS enhanced automatic gamma gun. You don't want to get shot by that. And what about this? Irradiated fresh ground beef. Depending on where you've been in the world, you might have seen something like that. So make sure you've got the definition above. So, yeah, what do you mean food is irradiated? As a pre-note, irradiated food must be labelled. So irradiation has been used to keep food safe in many countries around the world since the late 1950s. Decades of research have shown that irradiation of food is a safe and effective way to kill bacteria in foods, extend the shelf life of food, to remove insects from shipments of food. When food is irradiated, it absorbs energy. This absorbed energy kills the bacteria that can cause food poisoning in a similar way that heat energy kills bacteria when food is cooked. They can also delay fruit ripening and help stop vegetables from sprouting. Okay, let's move on. Sterilising medical equipment. So this is another use. So radiation is used to sterilise medical instruments by first sealing a clean but not bacteria-free instrument in an airtight bag, like this image on the right hand side. The bag and instrument are then placed in a very large field of radiation that can penetrate the bag. For example, gamma radiation, X-rays, or high-energy electrons. Ionizing radiations can kill the bacteria, and the airtight bag will keep the instrument sterile until the bag is opened in the medical facility. So if you've ever had a surgery, or you know someone that's had a surgery, the instruments that are used in the surgery will have undergone this process. So next up is shielding. This looks fancy. I have a picture here. So lead aprons protect staff. So lead aprons shield staff and patients from excess X-rays and gamma rays in a hospital. So that's that blue thing. The bottom right hand corner, the vest. We've also got lead-lined screens. They limit exposure to ionizing radiation from medical scans or procedures. So if you've ever had an X-ray or a CT scan or an MRI, when they do the actual scan, the member of staff that's conducting the examination or the process will stand behind a lead-lined screen to protect themselves. Lead absorbs all types of radiation, including gamma. And finally, gloves as well. Gloves protect specifically against alpha radiation. Alpha radiation, doesn't have a very, very long range in air, and it's stopped by skin. But it can get on the skin and cause damage. So gloves are very good protection. Gloves aren't very useful against beta or gamma radiation because beta can obviously travel. You need aluminium To stop beta or several meters of air, and to stop gamma you need lead or several meters of concrete. So gloves will not stop beta and gamma, but they are effective against alpha radiation. Okay, something else that you need to know that we brushed on in the previous lesson, tracer materials. So tracer materials are known as a radionuclide scan. It involves having a chemical put into your body that can be picked up by a scanner, similar to having a contrast dye for a CT or MRI scan. But in this case, the chemical, known as a tracer or radionuclide, is radioactive. The tracers give off gamma rays. As a further note, you don't necessarily need to know the ins and outs of this, but certain tumours and areas of the body absorb specific chemicals. These chemicals are made mildly radioactive and then put into your bloodstream. Because the tumours and or the area of the body absorb the substance, which is giving off gamma rays, they then show up on the scan, which is obviously very useful. So, for example, if you have radioactive iodine injected into a vein, the tissues of your thyroid gland quickly absorb it, so it can be used to take images of your thyroid. Very important, what you actually need to know is that when you have, a tracer material, the dose of radioactivity you get is very low, so it's got very low activity. It's probably about the same that, dose of radiation that you get from an X-ray. And almost all of it will leave your body within a couple of days. So how does half-life get involved? That's a syringe that holds a chemical. An injection of tracer material, radioactive nuclide, and it's surrounded by a lead box. So tracer materials typically have a half-life of approximately 6 hours. After 5 half-lives, the radiation will have left your body. If you want to see the mathematical proof for that, you need to get watching my A-level nuclear physics videos. Or you can just wait until you do A-level physics at school. So to protect the doctor that's administering injections every day, they wear protective equipment, which is the vest and stuff that we were talking about earlier, and they carry the radioactive injection in a special lead-lined syringe, like this image on the left. Let's put a Y in there. There we go. Right, okay, so what about dosing? So here's some badges. You've got John Doe and John Sample, obviously not real people. Dosimetry badge. So people who work closely with radiation, maybe at a hospital or a nuclear power plant, may have to wear a radiation badge. And the badge monitors the amount of radiation a person is exposed to over a year. And once a yearly dose has been reached, the member of staff will not be allowed back to work. So, for example, if you do something particularly risky or something happens and you're 9 months into your year, and you hit the yearly dose of radiation or exceed it, it's more than likely your employer, because they don't want to get sued into oblivion, will give you some time off work. I'd advise against, taking large doses of radiation to get time off work. There's probably better ways around that. All right, let's move on. So about contamination. So we've done quite a bit on irradiation. Some images from Chernobyl. So the first one is, just after the accident. Pripyat, Ukraine. Second one is modern day. As you can see, no one lives there because of the contamination. It's a rather cool image that I found on Google. Really clear. So radioactive contamination occurs when radioactive material is deposited on or in an object or person. So you actually get the radioactive material on you or on an object. Radioactive materials released into the environment can cause air, water, surfaces, soil, plants, buildings, people, or animals to become contaminated. So there is a distinct difference between irradiation and contamination. And you can be asked that in your exam. I'm going to give you an example, story from 2006 that involves a particularly dangerous, nefarious, and in the end lethal contamination. So that's contamination with alpha radiation, a source of a radioactive nuclide that gives off alpha radiation. And, alpha radiation can be particularly dangerous. So on 1st of November 2006, Litvinenko, a Russian national that was living in London, fell ill, and on the 3rd of November he was admitted to Barnet General Hospital in London. He was then moved to University College Hospital for intensive care. So this is Mr. Litvinenko, or Alexander as he was called. His illness, however, was later attributed to poisoning with a liquid form of polonium-210, which is a rather vicious alpha emitter. It was a high activity source as well, and it was put inside his tea in a cafe, or cafe, depending whereabouts in the country you are. Alpha emitters are particularly dangerous inside the human body, because if you think about it, they can't get out, and in liquid form even more so. Liquid forms of radiation are incredibly dangerous, more so than solid forms of the radiation. So the Health Protection Agency found large amounts of the toxic element inside his body, and this was Alexander a couple of weeks later, before he died. So he was killed by some Russian nationals. If you want to read about that story, it's quite interesting, and it's quite a distinct and scary reminder of the dangers of contamination. Anyway, I hope you found that useful. So you've got the definitions of, or explanations of, what irradiation and contamination are and how they are different. Quite a lot of examples for you to, obviously, if you've got the notes, sit down and learn properly. Anyway, thanks for watching, and I'll speak to you soon.